So next is position of P's. P represents this point, and we know that it corresponds to the point where both energies are equal. So it refers to minus A by root 2, which is minus 2 by root 2 as A is 2. So it will correspond to minus root 2, and Q will correspond to plus root 2. Now we are being given that EO. So what is the energy corresponding to that point? So obviously total mechanical energy is 20 joule, and EO corresponds to the position where both energies are equal. So half will be kinetic, half will be potential. So the energy will be 10 joule. Next is a block of mass 4 kg is fastened to a spring. Resulting motion of the block is. So it will be an SHM. So it will be periodic as well as oscillatory and SHM. So all will be correct over here. Next is time period of the motion. So time period is 2 pi root m by k. So here time period will be 2 pi root over m by k. So which is m is 4 here and k is 400. So this will be 2 pi by root 100, which will be 2 pi by 10, which is pi by 5. So first will be correct here. Next is frequency of the motion. Frequency is 1 upon t. So it will be 5 by pi hertz. Next is angular frequency. So time period is 2 pi by omega. So pi by 5 is 2 pi by omega. So omega here is gonna be 10. So first will be correct over here. Next is initial acceleration of the blockage. So acceleration is omega square x. Acceleration is omega square x, and omega square is here 100. X is 20, that means 1 by 5 in meter. So it will be 20. So third will be correct over here. Next is initial force on the blockage. So force is equal to mass into acceleration. Mass here is 4 kg. So if mass is 4 kg, then force will be m into a, which will correspond to 80 Newton. Then amplitude of oscillation will be, so initially it is at the left extreme. So from the mean position the displacement is 20, so that will be the amplitude itself. So it will be 20 centimeter or 0.2 meters. So both are correct. So third will be correct over here. Next is maximum speed of the particle is. So maximum speed is given by a omega. A here is 0.2 and omega here is 10. So that will be 2 meters per second. So first one will be correct. Next is maximum kinetic energy of the particle is. It is half mv square. So half into 4 into 2 square. So this is 8 joule. Next is kinetic energy of the particle at x is equal to 10 centimeter is. So let's say kinetic energy is K dash, so it will be maximum, that is 8 minus half m a square a square omega square sorry, here it will be x square, so it will be 8 minus half into 4 into 0.1 whole square into 10 whole square. So that will be 8 minus 2 into 1 by 100 into 100, which is 6 joule. So first is correct over here. Next is maximum potential energy of the particle is. So let's see if there is some initial potential energy or not. Yes, it is at the mean position the potential energy is 10 joule. So the maximum potential energy is going to be U is equal to U naught plus maximum kinetic energy. So that will be 10 plus 8, which is 18 joule. The first is correct over here. Next is potential energy at x is equal to 10. So here we can say that the total mechanical energy, or the maximum potential energy of the particle is 18 joule, which is also equal to the mechanical energy. So we can say that 18 is equal to kinetic energy at x is equal to 10 is 6 plus potential energy. So potential energy will be 12 joule here. So first is correct. Next is mechanical energy of the particle is it's equal to the maximum potential energy. So first is correct over here. Next is instantaneous position of the particle is. So as you can see, initially particle is at x is equal to minus 0.2. So if you substitute t is equal to 0, then it will correspond to this one. Yeah, third is correct over here. Next is initial velocity of the particle is. So you just differentiate it. Just a moment. So for finding velocity, you just differentiate this equation, and when you differentiate it, then we have differentiation of sin as cos. So it will correspond to the third option. Next we have instantaneous acceleration. To find acceleration, you just differentiate velocity. So it will correspond to the third option. Next is absolutely pure simple harmonic motion. So absolutely pure, they do not exist in reality, because there are certain dissipative forces which does not permit to move ideally. So second is correct over here. Next is in practical life, there exist systems which approximately executes SHM. So second is correct over here. Next is in simple pendulum, restoring torque is provided by the tangential component. Obviously the tangential